right? This is geometry, day 3, last day. All right. We're on page 11. We're going to talk about Pythagorean's theorem. Tell me everything you know about Pythagorean's theorem. Yes.
Squared plus b squared equals c squared.
Okay. That is the theorem. It is a squared plus b squared equals c squared. All right, what else do you know about Pythagorean's theorem?
Pythagorean made it.
Okay, excellent. Good job.
Good boy.
All right, what else? What else? Y'all know some other things, you're just not telling me. When do we use it?
To find the area of a triangle.
Say that. Oh.
Right.
It can be actually used for any triangle. However, it's only equal, the equality only works if it's a right triangle. So it is exclusively used for right triangles, all right? So if I have a right triangle and I give you those two values, there's only 2 parts to a right triangle, 2 names to the parts. There's 2 legs, leg, hypotenuse. All right? Is everybody listening? What's the longest side always of a right triangle? Always. 100% of the time. Always. Do you know why? Because it is, are y'all listening? It is opposite, it is the side opposite the largest angle in that triangle. If I have, everybody look, if I draw an acute triangle, that's the smallest angle. Would you agree? That's the smallest angle. The side opposite that smallest angle is the shortest side. If I draw an obtuse triangle, that's the obtuse angle. The side opposite the obtuse angle is
The largest.
the longest side, yes. So that means the side opposite the 90 degrees is the longest side, because can these be 90 degrees? Can these other angles be 90 degrees? What are they? What types of angles? They're always acute. The other angles of a right triangle are always acute, 100% of the time. Okay, it's going to be important when we get to our next semester. But I could solve for the hypotenuse by using Pythagorean's theorem. By saying 6 squared plus 8 squared equals the hypotenuse squared. Does it matter which leg I make A or B? No, it doesn't. It doesn't matter which leg I make A or B. All right? So, let's use our calculators. I already know the answer. 6, yes. Yeah. 6 squared is, y'all see the squared button?
How do I get this on the calculator?
Oh, okay. Look, I'm going to reset it. It's shift 9. And we're going to clear it.
No, 6 and
And we're going to say AC. That's
6 here.
Okay. Shift 9. We're going to clear all 3. And we're going to enter yes. Now hit AC. Okay, so we just cleared a calculator. Yes.
Do you have extra pencil?
I do. You need a pencil? You need a pencil. Okay. All right. Do y'all see the squared button?
Yes, ma'am.
Squared.
Do you see X squared?
Yes.
Yes, ma'am.
Okay, you can just use that button. You can just turn your calculator on. And you can do 6 squared and then hit plus 8 squared and hit equals. And what do you get?
100.
So we have the hypotenuse squared is 100. To solve for that, we then have to take the square root of both sides. Okay, so y'all already know what the square root of 100 is, but I'm showing you how to use a calculator. All right, so you see where x squared is? Okay, does everybody have 100 in there? Have you cleared it out?
Yeah.
You've cleared it out. Well, if you just hit the square root, which I have now 0 in there.
What's square root of 100? 10.
Yeah, square root of 100, you already knew that. Actually, if I input answer, you need a calculator?
Yeah, it's in that binder.
Get it. If you do answer, it should pop in 100 and hit equals. You get 10. Got it?
Yes, ma'am.
Okay, so do you see how I use the answer key? Look. 100 was my previous one. I just hit square root answer. It just pops in the previous answer. See that? It pops in the previous answer. Square. Well, your answer was 10. You already did 10. Got it? All right. So we could look at any triangle and know whether or not it's a right triangle. Because if I take the shorter two sides and square them, it should equal the longest side squared. So look at number 2. So there's this triangle. It's a 5, 12, 13. And we don't know if it's a right triangle. But could I figure out if it's a right triangle? Yes, I can. Because if a squared plus b squared equals c squared, and it works, then I can know it's a right triangle. It only works for right triangles. All right? So, what sides am I going to make my A and my B?
5 and 12.
Exactly. So I have to know that 5 squared plus 12 squared equals 13 squared. And does it, in fact?
Yes.
It does. Did y'all do the math on your calculator?
Yes.
It does. So those are actually 2 Pythagorean triplets that we will memorize this year. 6, 8, 10, 5, 12, 13. Another one is 3, 4, 5. This is the one that's been on the ACT lately, 5, 12, 13. Now, what about number 1? Is that 6, 8, 9? 6, 8, 9. Let's see if 6, 8, 9 works. 6, 8, 9. Is that a right triangle? Y'all tell me. Do the calculations. Does it work? It doesn't work, does it? All right. So that is not a right triangle. What about number 4? 3, 4, 5. Is that a right triangle?
Yeah.
It should be 9 plus 16 does in fact equal 25.
I get it.
Got it? Okay, now look at number 5. The triangle is not drawn, but sides are given. And the sides are 6.4, 12, and 12.2. is that in fact a right triangle? Is it? Someone says no. Anyone else agree? Do you agree, Lillian?
Yeah, I would do.
Yeah, it is not. All right, what about number 6? 2.1, 7.2, 7.2, and 7.5. Is that a right triangle?
No.
It says 225 over
225
4.
over 4. Yeah.
So this says 225 over 4.
Yes.
What does this say?
So is that?
So I guess it is right.
So it is.
It is a right triangle. It in fact is.
So if they equal, it's a right triangle.
Correct. And if they don't, it's not. All right, number 7, we're actually going to calculate the length of the missing side. So what side are we missing in number 7? What do we call that?
The hypotenuse, yeah.
Yes, the hypotenuse. All right, so 4, 8, and everybody calculate the hypotenuse. I want you to leave it in radical form. Arthur, are you calculating with us? Calculate with us. Number 7.
Square rooted.
Yes.
Yeah.
Yes.
It says it 4 in 5. 4 square. Yeah.
4 squared of 5. This is how we're going to answer problems. This is the calculator that leaves it in simplified radical form. That's why we're not using the Texas Instrument one, because the TI doesn't do this. Yes. All right, look at number 8. Now we have 3, 6. 3, 6, and give me the hypotenuse.
Square root of 5.
3 square root of 5. All right, number 9. Jonathan, you're going to give me the answer for this one. Everybody do it.
I got the square root of 149.
That is correct. Anybody else get the square root of 149?
Yes.
All right, Lily, do number 10.
I got the square root of 58.
For 10, everybody do 10. See if that's what she gets. See if that's what you get. You got square root of 58. Is that what you get?
Yeah.
Got it? Helen, do number 10 for us. 11 is what I meant. Square root of 53. All right, let's jump to 13 on the bottom. What are we solving for now? A leg. How in the world are we going to do that?
We do the same thing.
2 squared plus
So it's a squared plus
equals c squared.
2 squared equals 4 squared.
Do we have subtraction?
So we
You have subtraction.
subtract 16 from 4.
So it's a squared equals 4 squared minus 2 squared.
So it'd be 12.
And then you take the square root It's 2 square, it was the square root of 12, which is 2 square root of 3. In its most simplified form. Okay, while we're on our calculators, we're gonna go towards the end, all right? So 16 and 17, then we're gonna come back. So let's go to page 16 and 17. Then we're gonna come back to where we're gonna begin our year. We only have one chapter on trig. Trigonometry is the study of right triangles. So all of the triangles are right triangles. And let's just use one of these Pythagorean triplets, the 6, 8, 10, because we know that's a right triangle. All right, I'm going to label an angle. I'm going to label an angle with theta. That's how they label angles in your upper level maths. All right?
Wait, what's it called?
Theta. All right? So there's really 6 trig ratios. I'm only going to talk about 3 of them. In Algebra 2, we'll learn all 6. And in pre-calculus, we will be graphing them, all right? So, I'm going to teach you SOHCAHTOA. SOHCAHTOA, because Miss Haley likes a pedicure. Because what do you do when you get a pedicure? You soak your toes. Get it? Get it? SOHCAHTOA. Okay, y'all all please tell me you know this. Okay, it's because his brothers told him Miss Haley taught me this, and that's how he memorized it. So listen, it's SOHCAHTOA because Miss Haley likes a pedicure. Got it? SOHCAHTOA. Okay, this is what it stands for. Yeah. Toes. It is pretty common knowledge. Do you only have brothers? You have a mother. And you have a mother.
But, like, man, we never talk.
We never talk. All right, Lord Jesus, we need help in this family. Okay, listen. I'm just teasing. Okay. All right, listen. Are you ready? He is not.
He's cute as already.
Okay, y'all hang with me. I'm going to write some trig equations. SOHCAHTOA represents trig equations. There's always an x value, there's always a y value in equations, right? All right. So I'm going to say the sine, because S stands for sine. The sine of an angle equals O over H. You see how I get so? You see how I get it? Okay. All right. O represents opposite. H represents the hypotenuse. And O represents the opposite side of theta. All right, so look at theta. There's only one hypotenuse, and it's 10. So 10 is H. The opposite side goes from the angle to the opposite side. So that is the O. That's the opposite. I'm going to put O-P-P for opposite, but it's the O. That's the opposite side. The adjacent side is the 6. It's the adjacent side. So if I had drawn my triangle with theta here, this would be H.
That would be
Correct. And that is A. sense? Depends on where your theta is. So if I were to write the sine of theta equals opposite over hypotenuse, I could actually substitute numbers in for the opposite over the hypotenuse. So the sine of theta equals the length of the side opposite it, 8, over the length of the hypotenuse, 10. Make sense so far? So I could give you any triangle. We'll make that theta. And we'll do the 5, 12, 13. So here, the sine of theta equals the length of the side opposite, which is, does everybody see that 5 is opposite theta? Does everybody see that? 5 is opposite theta over the length of the hypotenuse, which is 13. Arthur, you with us? Always want your face to tell me that you're paying attention. Right? All right? Makes sense? Makes sense, Clyde? Got it? Okay. Now, so, S-O-H, so, sine of an angle equals the length of the opposite side over the length of the hypotenuse. Got it? So far. This is an intro. Because when I teach it for the first time, it's so nice for y'all to have heard these terms. Okay? So, ga. That's the cosine. This is how it is spelled, cosine. Actually, sine is spelled S-I-N-E. That's the whole word. It's abbreviated S-I-N. All right? The cosine is abbreviated C-O-S. The cosine of any angle equals A over H. The adjacent side over the length of the hypotenuse. So in this triangle with theta, the cosine would equal the adjacent side, 6, over the length of the hypotenuse, to 10. Got it? And for this one, the cosine of theta would equal the adjacent side, which is 12, got it? Over the hypotenuse, which is 13. Make sense so far? All right, so sine equals opposite over hypotenuse. Say that. Sine equals opposite over hypotenuse. Say it with me. The sine equals opposite over hypotenuse. Okay, Arthur didn't say it with us, so let's say it again. The sine equals the opposite over the hypotenuse. Okay? We're going to do lots of recitation in this class, and we will repeat it until everybody repeats it. So you just should do it the first time. I will tell you the students that are in my Algebra 2 camp, immediately. I could start a sentence, they could finish it for me. You know why? We repeat it. We repeat it. We repeat it. Because you learn, right? Therefore, I know you know it, all right? All right, sine, opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Say it with me. The cosine equals the adjacent over the hypotenuse. So it's SOHCAHTOA, then it's TOA. Does TOA look different? It doesn't have what part in it?
The H.
The H. That is correct. It does not have the hypotenuse in it. It's called the tangent, but we abbreviate it TAN, and it equals the length of the opposite side over the length of the adjacent side. It's a ratio. So the tan of an angle equals that ratio. the ratio of the opposite side over the adjacent side. So here the opposite side is 8, and the adjacent side is 6. If I were to do the tan of theta for this one, the opposite side of theta is 5. Does everybody see that? The opposite side of theta is 5. Does everybody see that? And the adjacent is 12. Got it? Make sense? All right, I'm going to draw another triangle. And I'm going to put theta there. And I'm not going to tell you what the answer is. That I know is a Pythagorean triplet. I'm going to erase this. It's SOHCAHTOA. SOHCAHTOA. All right, you remember it? SOHCAHTOA. You remember it? SOHCAHTOA. Sine, cosine, tangent. So, opposite over hypotenuse. Ka, adjacent over hypotenuse. Toa, opposite over adjacent. All right? Now, Clyde, you see where theta is? I want you to give me the sine of theta. What's the ratio?
1/√3. Or it's hypotenuse too.
Correct. It's so. Got it? Got it? All right, Liam, give me the cosine of theta.
Whatever. √3.
Is not, but this is so ka. Can you help him, Lily?
Can we do the square root of 3 over 2?
Yes, and can you explain that? Why?
Because it's the base
Yes.
over the hypotenuse.
Yes. Are y'all getting this? Getting it? Yeah? All right. Then the tan of theta. Lillian, can you help me with the tan?
1 over square root of 3.
Yes. You got it? Is everybody getting this? Okay, I want you to look on page 16. You look on page 16, there are a bunch of right triangles drawn. Okay, we're gonna go around the room. Remember, it's SOHCAHTOA. I may or may not ask you the question that is on the sheet. I just want you to give me the ratio. All right, you ready? Number 1, this Luke M. What is the sine of angle C? Just tell me something over something.
Oh.
Something over something.
29 over 21. Are we on?
We're on number 1, the sine of angle C. So, okay, you were so
Or
close.
is it 29 over 20?
29 is not in the numerator. So is, Jonathan, it's 21 over 29. The opposite side of angle C over the
Yeah,
hypotenuse.
I was doing it the opposite.
You were. You were. No, you were doing hypotenuse over opposite.
Oh yeah, doing it wrong.
Okay, so I'm going to give you another chance. For number 1, what is the cosine of angle A? For number 1, the cosine of angle A. We're going to let Luke try. Cosine is what? So,
I have a question.
what's your question?
When you say cosine of A, does that mean the theta is on A?
That's the angle. Yes. Yes. Okay, so it's the cosine of angle A.
It's something over 29.
That is correct.
I don't. Is it 21 over 29?
Yes.
Okay.
Because 21 is the adjacent side to angle A. Does everybody see that? Got it? All right, Jack. Number 2. What is the sine of angle C?
30 over 50.
Correct. Does everybody see that? Opposite over hypotenuse. Got it?
Is it the opposite because it's where they keep you?
Well, we go to angle C and we go to the side opposite. Well, that's what I asked. I could have asked A.
And then it would be the opposite from A, which would be 40.
Correct. Yes. All right, author. I want to know the tan for number 2. We're still on number 2. I want to know the tan of angle C. The tan of C. SOHCAHTOA. TOA is tangent equals opposite over adjacent. So if we're looking at angle C, what's the opposite?
Is it 30 over 40?
30 is opposite angle C.
30 over 40.
Yes. Do you see that? You see it? Does everyone see this? Maybe? Kind of. Okay, Helen. Number 3. The cosine of angle C.
It's the adjacent over the height.
Hypotenuse, yes?
So, it's the adjacent to what angle?
C. Angle C.
It's always equal C, or?
No, that's what I asked. I could have asked angle A, but I asked angle C.
Okay, so it's 36 over 39.
Yes! Very good. Okay, Lillian, I'm going to ask, still on number 3, what is the sine of angle C? The sine of angle C.
15 over 39.
Yes! Y'all are doing trig. Isn't that amazing? Okay, I'm so excited. All right, number 4. This Luke. Number 4, the cosine of angle C. For number 4, cosine angle C.
15 over 17.
Okay, cosine. So,
15 over 17.
what does 15 over 17 represent?
Wait, yeah.
Would that be the
right.
sine?
That's the sine.
8 over 17?
Yes! 8 over 17. Got it? Okay, we're going to go to number 5, Jonathan. The tan of A. Tan of A, Jonathan, for number 5. Yes! 12 over 35. Yes?
What does the A stand for?
Adjacent.
So it's adjacent to the opposite.
So if I draw number 5, all right? This is the adjacent. That's the hypotenuse because it's opposite the 90. Opposite angle A is over here. Because, okay, remember I said if it's an acute angle, the side opposite is short, but if it's an obtuse angle, the side opposite it is big? Because an angle determines the length of the side opposite that angle. Make sense? Okay. Liam, number 6. The tan of angle X. Okay, tan, what's the ratio for the tan? The tan equals whatever what? SOHCAHTOA. SOHCAHTOA. TOA. Come on, Liam, you got this. Okay, I want you to hear it. So, S-O-H. Ka, C-A-H. TOA, T-O-A. So is S-O-H. Sine equals opposite over hypotenuse. Ka, cosine equals adjacent over hypotenuse. TOA, tan equals opposite over adjacent. So it's TOA. Yes! Okay, so looking at angle X, the tan of X equals, what's the side opposite angle X?
36.
Yes, 36 over the adjacent side.
27.
Yes! Good job! All right, Lily, number 6. We're going to do the sine of X. The sine of X.
40, 36 over 45.
Yes. All right. Now, if we go back to 17, we have equations, but we've not given the ratio of the sides. All right. Look here. If I said the sine of theta is 1/2, I already know the angle because of trig. But it could be the sine of theta is 0.5. That would represent 1/2. Would you agree? I know that that is a 30-degree angle. And I know that that's going to equal 1/2. I already know that. All right, but let's say we didn't know the ratio. Yes?
For tangent, is it, what is it opposite over?
All right, so do you see the sin key on your calculator? Does everybody see this SIN key? All right, I want you to hit the sine key, and it's going to give you parentheses. Okay, we're going to put the angle in there, 30 degrees. No degree, just put 30, and then hit equals. And what do you get?
1/2.
1/2.
It's 1/2. It gives you the ratio. If I know the angle, your calculator will give you the ratio of what the opposite side over the hypotenuse equals. All right, now, that same angle is 30 degrees, right? Because it's that angle. So if I did the cosine of 30 degrees, I should get the square root of 3 over 2. All right, so hit COS, yes.
I put in the sin of 30, it gives me like a...
Oh, that's your brother's calculator.
Yes.
Let me fix it. Okay, you were in radians and not degrees, which is a different measure. But I immediately knew that was Landry's calculator. Did everybody get 1/2? Okay, now do the cosine of 30. COS 30 equals. And what do you get? Square root of 3 over 2. Okay, this is the same angle, right? This one's going to be a little different because in algebra, we don't leave radicals in the denominator. And because that has no equal sign, all I can multiply by is what is equal to 1. So we do what's called rationalizing the denominator. Did y'all do any of that last year? Okay, well, I'm going to just show you real quickly. We multiply by the radical over itself. So that becomes square root of 3 over 3. Because that's the answer the calculator is going to give you. If you do, let's do this. Do 1 divided by square root of 3 in your calculator and hit equals. Yes, so you get square root of 3 over 3, right? Your calculator will rationalize it for you. So 1 over square root of 3 is the same exact number as square root of 3 over 3. It is a rationalized denominator. All right, so if we do the tan of 30 degrees in your calculator, you're going to get square root of 3 over 3. So do the tan of 30 degrees equals, and you get square root of 3 over 3, right? All right, look on page 17. I don't know what the ratio of the sine is for a 62-degree angle, but I can use my calculator to figure it out. All I enter is sine 62 and hit equals.
0.888927.
Yes. So that's a very small number. Trig, because we're in trig, everybody listen, we always go to 4 decimal places. So if I'm doing the tan, no, that was the sine. The sine of 62 degrees, I'm writing 0.8829. It would never be written 0.8829. You always have 1 digit to the left of the decimal place and 4 digits to the right of the decimal place. All right? So, Liam, do number 8. What's the sine of 14 degrees? That is correct, 0.2419. Clyde, what's the cosine of 60 degrees? 1/2. Okay, in trig, if I can write it as a ratio of numbers, I write it as a ratio of numbers. I would write 1/2. I would never write 0.5 in trig. I would write 1/2. Got it? All right, number 10, cosine of 31, Lillian. Cosine of 31. What does that equal?
0.8571 or
2, that's right. Round it to that 4th decimal place. 0.8572. Jonathan, what's the tan of 79 degrees?
5.1445.
Round it. 5.1446. Because it's 0.14455, which makes you round it that 4th decimal place up. Does that make sense? All right, Jack, what's the tan of 25?
0.4663.
Yes, that is correct. All right, why do we learn trig? Because a lot of life deals with trig, actually. If I graph a trig function, this is what it looks like. What does that make you think of?
The oceans.
Okay, waves on the ocean. Yes. What else does it make you think of?
Desert dunes.
Desert dunes, okay. Anything else?
Wave sounds.
Sound waves, yes.
Radio signals.
Radio signals, yes. Have y'all ever visited a hospital?
Oh, like the.
And the heart monitor machine, that's what it
One goes in a
does,
straight line.
right?
That's what I thought.
Not, a straight line is not good.
I don't know how he's still on.
Okay, so all of that, and actually, what happens when if I had a football in my hand, do I just throw it straight?
Spiral.
But do I throw it straight? Or do I throw it, if it's a short pass, I'm going straight. But if I'm going a Hail Mary, what am I doing? I'm throwing it up. That's trig. Yeah.
I like it.
If I shoot hoops, right?
You did in a curve.
Do I just go boom? No, I do this, don't I? That's trick. Okay, so it's really all around you, and you never really knew that it was all around. Even baseball, when you hit a ball, okay, some of them are line drives. Those are the most dangerous, right? But if you're putting it over the fence, are you hitting a line drive? No, it's going to have arch to it, right? Of course, the wind impacts it. All right, so trig is actually all around you. It's all around us now because we have these radio waves that we don't have a clue that are going through our bodies right now. So if I don't know the length of the side of a right triangle, then I can use trig to solve for the length of that side. All right, so everybody look. Here's my angle. What side is X in relation to that angle? Is it A, O, or H?
In relation to
59 degrees.
It's O. It's opposite.
It's opposite. You see that? Oh, yes. And what is 17?
H.
A.
It's the hypotenuse.
H.
You got it?
Yes, ma'am.
What trig ratio uses O and H? Sin. So, if the sine of theta equals O over H, I know what theta is. What's theta? 59 degrees. I could say the sine of 59 degrees equals, I don't know what O is.
Zero.
I don't know what it is. I'm going to leave it X. But I know the hypotenuse is 17. Can I put this in my calculator?
Yes.
Yes. So Luke, tell me what the sine of 59 degrees is.
0.8572.
How do I solve for X? This is algebra. What? Okay, how? I want X equals. How do I get X equals?
You divide 17 on both sides.
Do I divide?
Multiply.
Why do I multiply?
Because it's the 17 is underneath. It's already divided. by-
Because it is divided. And I do the inverse operation to get it to the other side. That is correct. So if I multiply both sides by 17, those cancel. And what is the length of the opposite side? What's 17 times that? What is it, Jack?
14.5718.
Okay, this is where I always want you to engage logic. Is that reasonable? What makes 14.5 reasonable? it better be less than
17.
the hypotenuse. Right? If you solve for the length of a side and it's more than the hypotenuse, your brain should say, you did something wrong. I always want you to look back and ask yourself, is my answer reasonable? And it is. All right, let's look at number 14. Did you ever think you'd be doing trig? You can go home and tell your people, we did trig today. Okay. Are you not as excited as I am? A little bit? A lot? I am good. Thank you. All right. Now, here's the angle. What side is X on?
Opposite.
Does everybody see it's the opposite? Does everybody see it's the opposite? And what side is 17 on? Does everybody see it's the hypotenuse? Does everybody see that? Which trig ratio? I did the theta.
Sin.
Right! It's the sine. So the sine of theta equals opposite over hypotenuse. What's theta?
60.
60 degrees. Does everybody see that?
Yes, sir.
So the sine of 60 degrees equals, what's opposite?
X.
X, we don't know yet. And the hypotenuse is,
17.
can I put this in my calculator? Yes, I can. Lily, give me what the sine of 60 is.
The square root of 3 over 4.
All right, now can I solve for X?
Yes.
Yes. How am I going to do that, Clyde? How am I going to solve for X?
Multiply and multiply.
It's the same exact thing we did last time. So X, your calculator should leave it like that. If you multiply square root of 3 over 2, does it? Please tell me it does. Yes, thank you. All right, let's look at number 15. Same page, 17. I'm going to draw it over here. All right, so this is number 15. All right. You ready, author? Here's the angle. What side is X to that angle? Remember, we have three options. O, A, H. Opposite, adjacent, hypotenuse. X is O opposite? It's the biggest side, opposite the 90-degree angle.
Say.
It's A. That is A. Because H is always opposite the right angle. Got it? Everybody got it? Okay, so listen. We have adjacent. We have the hypotenuse. What trig ratio am I going to use?
A cos.
Ca, which is cos, which is cosine. Yes, cosine. Cosine, what am I going to write next to cosine?
27.
Cosine of 27 degrees equals what over what? X over 20. What is the cosine of 27?
0.8910.
All right, so how do I solve for this?
Divide times 20 both sides.
Multiply by 20 on both sides. And what is the length of that side? It better be less than 20, right? Is it less than 20? What's 20 times 0.891?
891 over 50.
Hit S to D.
17.82.
17.82. Okay, 16 is going to feel a little different. And I'm going to tell you something that I'm going to repeat a lot this year. Okay, everybody see that angle? See the angle? It's 51 degrees. Got it? Okay, Jack, what is 10 in relation to that angle? Jack, I didn't mean Jack. I meant Luke.
10 in relation to what?
To 51 degrees. What side is
Is
that?
that A?
It's A. It's the adjacent. And X is?
Well, it's opposite of the right angle, so it'll be H.
It's H, yes.
And then
All right, so how am I going to write my equation?
H over
Well,
A.
which equation am I going to use? Am I going to use sine, cosine, or tangent?
Wait,
No,
case.
Cos, because we have Got it? So I'm going to write the cosine of what? 51 degrees equals what?
0.6294.
But what am I going to write on this side of the equal sign? Equals what over what?
X over A. Or A. H over A.
H over A. X
No.
over A.
A over H.
A over H. A over H. Okay, is everybody listening? Like I need to know you're listening. So now we have 0.6294 equals 10 over X. Okay, I'm going to say something that I'm going to say a lot this year. I'm going to show you is that a true statement?
Yeah. Yes. Yes.
Okay. These are called your extremes. There's no new words. These are called your means. I can swap my extremes without changing the value of an equation. My extremes are easy. I can move the 4 there and the 4 there. Let's make it 6 over 3. Is 6 over 3 correct? That's also 2. Okay, let's swap our extremes. I'm gonna move the 3 there and the 4 there and see if that changes anything. So 3 halves equals 6 fourths.
It's the same thing.
It's the same thing. So I can swap my extremes. Okay, let's go back here. I can also swap my means without changing the value. Okay, so I'm going to move 6 here and 2 here. Got it? So that's 4 over 6 equals 2 over 3. Same thing. Okay. All right. I need to erase this. So I'm going to tell you when we have X in the denominator, everybody listen, when we have X in the denominator, I'm going to tell you to swap your extremes. If this is over 1, we're going to swap these 2. So I'm going to move X over here, and I'm going to move 0.6294 over here. See what I did? Swap your extremes. X over 1 is just So the value of x is 10 divided by that. What is that? Do the math.
0.06294.
Do 10 divided by 0.6294.
15.8881. 882.
Wait, you got 882. How'd you get that?
15.8882 or more.
Did you do 10 divided by 0.6294?
It's a fraction. It's a fraction.
And hit S to D.
Okay.
Got it? Got it? All right, let's look at 17. Actually, what time is it? Who has the time?
313.
And we have until,
313.
okay, let's move back to geometry. Okay, y'all have done, okay, I got way too caught up in trig, because I love trig. All right, I'm glad you do. It's going to be so much fun. We're going to do a lot, not this, we're going to do some, but, all right. Your entire first semester will be conditional statements. Y'all have written conditional statements, right? Conditional statements come in the form of if, then. So I could write it if the shape is a triangle, then it has 3 sides. Is that a true statement? That is a true statement, right? So all your conditional statements are first, this is what we're going to do, our very first chapter, conditional statements. We'll do if-then statements. Such that the if statement is the hypothesis. It is like the condition. It is the condition. The if statement is the condition, not the hypothesis. And the then statement is the hypothesis. If this condition is met, then we have something that will actually happen. Make sense? Or the conclusion. Okay, never mind. It's not the hypothesis, it's the conclusion. Condition, conclusion. Let's use my markers. Condition, conclusion. Conclusion. If we have some condition, then we can draw some conclusion. Okay, y'all have done this with syllogisms. Do y'all remember syllogisms? Okay, what logic have y'all taken? Y'all have taken logic, right? Has it been a while?
I mean, since last year.
Took like introduction.
S.
And what's it called? Introduction.
All S is B.
Okay, look on page 14. Look on page 14. The condition is the hypothesis. I wrote it correctly the first time. But I like to call it condition conclusion. Your book does call it the hypothesis, and that's the conclusion. All right, so look at number 1 on page 14. If the shoe fits, then you can wear it. You know, it's always if A, then B. Or if P, did y'all use P and Q? Then Q, right? Y'all probably use P and Q. My markers are dying. All right, so if you're thinking about the condition and the hypothesis, what is the condition to number 1? On page 14. What's the condition?
The condition?
What's the condition of number 1?
If the shoe fits,
Uh-huh. And what's the conclusion?
Then you can wear it.
Then you can wear it, right. So number 2, what is the condition?
if you are a lawyer,
Being a lawyer, then what?
you
You
pass
pass the bar exam?
Yeah. All right. So you remember Venn diagrams?
Like, I know the word.
You remember Venn, the 2 circles. Yes. 2 circles. So a Venn diagram, in geometry, we're going to call them Euler diagrams. Because Euler. No, Euler because he was a mathematician. All right. So if I were to write this as a Venn diagram, number 1, it would be like shoe fits, then you can wear it. But we're going to call them Euler diagrams in geometry, right? If I were to write number 3, if I were to draw a Venn diagram or a Euler diagram for number 3, what would be in the smaller circle for number 3 on page 14?
If it is a fish.
Fish. It would have to be a fish. Then
Lives
what?
in water.
Water. Lives in water. Got it? You get conditional statements?
Yes.
Okay, you have actually done proofs in Algebra 2. In Algebra 1. Y'all are not in Algebra 2. But in Algebra 1. And we're going to walk through a proof that looks like what you guys have done. So look at the bottom of page 15. In every proof in geometry, you're going to have given statements, and we're going to have to prove something. Okay, I always want you to write the given statements first. We're only going to do 2-column proofs in geometry. There are actually 3 ways to work proofs, but we're only going to do 1. Okay? It'll always be 2 columns. So we'll have our statements, and we'll have our reasons why we can make those statements. Everybody listen. The very first statements you're going to write are the given. So watch me write the given. This is my reason. That's worth points on a test.
So you just have to have given?
Yes, because it is given. But you know what? I have students that don't write the given statements on a test. And they are right there on the page. Points. Given. Okay. Now, we're going to begin solving it. What would you do to this first equation? What would you do to this first equation?
Parentheses.
Okay,
So
you're
it's
using
6x
plug-in.
Plus 8, 6x plus 8.
you distribute 2 to 3.
Distribute. Okay? Okay? Distribution. You tell me the reason. Okay? What would you do next? Somebody said it. Okay? But how? Jack, you said it, but you didn't use a math term. but that's not math language. If I would substitute for y 20, okay, now what would you do?
The 8.
Move the 8
The-
over the 20.
Subtraction.
Divide both sides.
Division.
X equals 2.
So you've actually been working proofs. You just didn't write your justification, your reason for each step. This is what a geometry proof is going to feel like.